Good afternoon, everybody. So this is a follow-on live coding tutorial following my introduction to Docker. This is Evan Morgan again. And what we're basically going to be doing right now is defining a Docker file, using that to build our Docker image, and then using that image to bring up our own container. So Docker have supplied a GitHub repo as a sample application, which I can put down in the description for you below. And what it details essentially is a small application that you can add things to a list. It has its own Express server as well. We can see here in source. In index.js, it uses Express. It has these different endpoints as well, but we'll just be using the front end, and we'll be testing it out on localhost. So in order to do this, first of all, we need to be inside the app folder. And we're going to create our own Docker file. We can ignore all of this. It's not necessary for our purposes. We just need what's in app. So if I create a new file here and I name it Docker file, we can exit that. So yeah, the first thing that we're going to do is essentially an image is built a lot like an onion. It's got loads of layers, and we want to start with the very core of that onion, which in this case is going to be a Linux distribution called Alpine, and there is already a version of this. There is already an image of this distribution with Node pre-installed on it, so I'm going to use that, and I want to use Node 12 specifically, so I can use Node 12 Alpine, and that is going to supply us with the snapshot of the file system inside Alpine, as well as pre-installed NPM and Yarn and Node, which is great for what we're going to do. The next thing is that this application requires us to use Python, G++, and Make in order for it to run. So we're going to build a layer on top of the core now with the run command. And run basically runs whatever you tell it to as a command, and then it closes off that layer so that the next line will be able to use anything that has been installed on the previous line, and it kind of builds on top of each other that way. So we're going to use APK to add Python, G++, and Make. We need those, and we're also going to tell it to not cache any of these. So after this, and that's done, so that seals off the layer now. What we want is we want our application to be copied inside of the container itself. So usually when developing, you can develop this separately and use Node on your local machine to test it out in any way that you want, or you can use the Docker container as well. But once that's done, you'll have all of your application within the app folder, and you'll want to copy it in by using copy. So first of all, I'm going to set the working directory to be /app, so that's here, and then I'm going to tell it to copy everything from my local machine, which is the source, to the home directory in the container, which is the destination. So after we have all of this, we now have the package.json inside of the container, and that obviously contains loads of packages that we'll need for this, like Express, MySQL, etc. And what we're going to do is we're going to run yarn install, and we're going to run it, because we're not developing with this, we're going to run it in a production setting. So we add that option there, and it won't install any of the dev dependencies. And that's pretty much it. That's our final layer. What we need to do now is we need to just add in a default command. And this is the command that runs if you don't supply the container with any argument to run when it is starting up. You can run a container and then supply it with an argument to run, in which case this will override this command. But we want to do this by default. So I'm going to supply an executable now, which is node. And I'm going to supply the first parameter, which is going to be the target, which is the index.js file that we just saw here with all of the definitions here. So, and that's pretty much it. You've defined your Docker file. So this is effectively our blueprint for the image that is kind of a prefab for this container, and then we can then run the image and it will spawn a container. Okay, so now that our Docker file is completed, I can open up a terminal here. I'm using WSL, so Windows Subsystem for Linux, and because I use a Windows machine, it's a lot more helpful to run Docker inside here. So I'm going to navigate to the app folder where you can see our Docker file is. There it is over there. And what I'm going to do is I'm going to use the build command to use Docker to build an image based off this Docker file. Now this image is probably going to take up a couple of 100 megabytes just based off the fact that we're using node modules to install things, and we obviously have added in Python, G++, and Make. Alpine itself is probably only going to take up a couple of megabytes, so we don't need to worry about that. But because it's going to be quite large, and just for good organization purposes as well, I'm going to add a tag to this image that is going to be my cool image. And I'm going to start building this. I need to target the current folder as well. Okay, great. So it's just finished running all of our commands here, and I've edited this out just because it can take some time, like the running commands taking 20 seconds and 15 seconds and so on. But you can see from what it's being done here, building took 61 seconds in total, and it was downloading Node 12 Alpine, and after that running our commands and installing everything. And then finally exporting to image. So we can now see, if we do Docker images, we can see my cool images here. Great, and it was created 38 seconds ago. Brilliant. So let me just check now to make sure that no containers are running. No containers are running. Great. And we are going to start running our application. So we're going to use Docker run for this. We're going to run it in detached mode. So if we weren't going to run it in detached mode, our terminal would be taken over and it would be logging out things from the container as it was going. We don't want that. We can always get the logs through different methods, like Docker logs, and we just want it to run in the background. So we can run detached here, and we also need it to run on port 3000. So this particular application exposes it's running on port 3000, but that's on the container. And we want to be able to access it through our local machine. So we need to port forward from 3000 on our local machine to 3000 on the container. And once we've done that, we just need to target what our image is. We can also add in a name for our container. So we could say my cool container. But if you don't supply that, you can see that it will actually, so that's the SHA. But you'll actually see that the name will be auto-generated. So if we check what is running now, and let me just spread that out here, you can see that my cool image is the image, but the name will be Suspicious Lewin, or it will generate its own random name based off fun little things like this. So we can see it is forwarding those ports, and it's been up 8 seconds. So let's have a look. I'll use Chrome for this. And let's go to localhost 3000, and we can see our application is up. So the next question probably is, how do I stop this container? So the thing is, your image right now is probably taking up hundreds of megabytes of your precious storage space. And I'm just going to add and delete some things here to make sure it's all working. Yeah, brilliant. So the next thing you're going to want to do is you're going to want to kill this container. And you do that by doing a docker ps and then by just taking the container ID and pasting that in there. And bam, you can see that it no longer will exist. If I go back to localhost 3000, it will eventually time out, but you can see it can't contact it immediately. There we go. So next up is checking your images. If you wanted to remove this image, you could do RMI and go for the image ID. Unable, must be forced. Images being used by stopped container. Right. So we just stopped the container. We didn't completely remove it. So you can always check what commands you're going to need here. So if I just try to remove this container, let's see, and everything is now removed. Brilliant. So let's try that command again. Basically, we couldn't remove the image because it was in use by a container. Even though that container was exited, it could still technically be restarted. So let's try and remove that now. Brilliant. It's been untagged. It's no longer my cool image, and it's been deleted. And the very last thing that you might want to do is pruning your cache, which I believe looks something like this. Let me see. From memory, I can't quite get it. There we go. Docker system prune. And yes, you do need to make sure that all of these, all of your containers are stopped. There are no networks used by the containers, anything like that, or any images that are still around, because they'll all be deleted. So there we go, 300 megabytes reclaimed. And that is it. So thank you very much for watching. If you do have any questions, please put them down in the comments. But this has been great. Thank you.